Okay. Hello, I'm Louis-Philippe from Carnegie Mellon University. Today, I'd like to talk about how Big Five personality traits impact the generation of individual nonverbal behaviors. Let me start by briefly talking about nonverbal behavior generation. So nonverbal behavior generation from spoken text and speech is key technology for achieving natural conversational agents and robots. There are mainly two types of generation target. The first is reproduce faithful movements of a skeleton pose tailored to the individual's style. If we can do this, it will greatly contribute to the generation of realistic movements for personal CG avatars that have a skeleton similar to humans. The second is a generated behavior level using the same input features. For example, the types of generation estimated is at the hand gesture type level that accompanied each spoken word. This will contribute to the generation of movement for non-realistic characters that don't have a skeleton similar to humans or cannot agile movements as humans do. In this research, we study the impact of the agent's personality on the behavior level generation using text information. So next, let me talk about nonverbal behavior and personality traits in humans. First, human nonverbal behaviors vary greatly depending on the personality of the individual. Some studies have demonstrated that the Big Five personality traits affect some nonverbal behaviors. And as the study has shown that humans can perceive differences in the Big Five personality trait of agent on the basis of differences in their nonverbal behaviors. These studies support the argument that the humans would have a more natural and positive impression of an agent if it can generate nonverbal behaviors consistent with its personality given by the designer. So our goal is to create a new generation model that can predict nonverbal behaviors reflecting an agent Big Five information taken as input. So in this research, we study how Big Five personality traits impact the generation of the individual nonverbal behaviors. Let me introduce the flow of this research. First, we constructed a new dialogue corpus that contains the time series data of participants' verbal and various nonverbal behaviors and the Big Five for Japanese dialogue. Second, we performed an experiment to determine the usefulness of Big Five for nonverbal behavior generation. Third, we analyzed the relationships between each of the Big Five indicators and the nonverbal behaviors in detail. First, I will introduce our corpus. We collected 28 face-to-face two-person dialogues with 11 pairs of people. A total of 22 people participated. Each pair had 2 or 3 conversation sessions. The conversation contents were storytelling and discussion. And each session was about 10 minutes long. So we obtained roughly 280 minutes of dialogue. Spoken texts were manually transcribed. We collected 6,967 utterances, including 90,827 phrases, each of which consists of at least 1 contents word and 0 or more function word. A phrase is a minimum unit that conveys the semantic contents in Japanese. So we extracted several kind of motion level for each of 7 behavior types, such as eye gaze, head nod, 3D head direction, hand gesture, and upper body posture. These actual human behavior levels are our generation target. Let me introduce the corrected Big Five data. To assess the Big Five score for each individual in the corrected dialogue, we asked 10 annotators to watch all conversational videos and fill out a questionnaire to provide the Big Five scores. Each dimension of the Big Five personality traits was given a score from 1 to 7. The mean ICC score, which indicated the inter-rater agreement, was 0.668, which is high. So this means our Big Five data are reliable. We used the mean value of each indicator of Big Five as a Big Five score of each individual. Next, I will introduce our experiment. For analyzing the importance of Big Five information in nonverbal behavior generation, we implemented a behavior generation model with and without a Big Five for each behavior type individually. This slide shows a prediction model without a Big Five information. As the architecture for our generation model, we chose a bidirectional LSTM plus CRF to take advantage of its ability to model temporal dynamics from a smaller number of training samples. The input features of this model are sequential phrase embedding text features for a sentence. The model can generate one nonverbal behavior level for each phrase as output. For the model with the Big Five information, the Big Five features were concatenated with the text features before the CRF layer. We implemented these two models with and without Big Five for each of the 7 behavior types individually. These are the details of our experimental setup. We used 2 kinds of text features, word to back and bird. These were extracted from a well-known Japanese model pre-trained with Wikipedia. We used 6,968 utterances in our dataset. The data point included spoken text, 7 kinds of behavior type for each phrase, and 5-dimensional Big Five score for each speaker. We used the ribbon out cross-validation technique to evaluate our models. We compare the performance of the generation models with and without the Big Five using different text features for each of the 7 behavior types individually. So this slide shows the mean of the measure for each model. We compare the performance of the model with Big Five. So with Big Five and with the Big Five. So when using either word to back or but as the features. The F measures indicated here by the yellow markers are the area where the prediction performance significantly improved when using a Big Five. So these results demonstrated that models with Big Five for eye gaze, head nod, and hand gesture, and upper body posture performed better than the model without Big Five. So however, Big Five was not useful for the generation of a head direction. Here next, we investigated which of big five indicators were useful for generating which type of behavior. For this analysis, we constructed a model that did not use one of the indicators and then compare the performance to models using all big five indicators. So the F measure indicated by the blue marker here, the area where the prediction performance was significantly lower than one of the model using all indicators. These results suggest that the openness indicator is useful for generating eye gaze, hand gesture, and upper body postures. Conscientiousness is useful for hand gesture, and agreeableness for head nod, hand gesture, and upper body posture. And neuroticism is useful for upper body posture. The extroversion indicator was not useful for any of the motion types. This seems somewhat surprisingly, as some studies have suggested that extroversion affects human nonverbal behavior. However, our results don't support this trend. The reason could be due to cultural difference or small amount of data in our data set. So finally, we performed a detailed analysis of the big five indicators that were useful in the experiment and how they correlated to nonverbal behaviors. Due to time constraint, I'll forego a detailed explanation, but we did find a lot of relevance as shown here. For example, for the openness indicator, the result suggests that the higher the openness indicator, the more looking at the listener, the more performing the iconic and beat gestures, and the more focus on the center of the upper body. So it means that no learning. In conclusion, we have demonstrated that the big five personality trait can help improve the nonverbal behavior generation. And we also demonstrated which indicator is useful for which nonverbal behavior. In the future, we would like to collect the larger data set and implementing improve the prediction model. And we also plan to evaluate it whether users can perceive differences in an agent personality trait from nonverbal behaviors generated by our model. Okay, thank you for your attention.